everyone, my name is Liz Gonzalez. Today I will be talking about cartographic projection.
They are awesome and approximately spherical shape, but most are flat. Because of this, it is not possible to represent the Earth's surface on a sheet of paper without some distortion. To solve the problem, cartographic projections are used. These are mathematical methods that make it possible to transfer the Earth's paper surface onto a flat surface. Each projection has advantages and disadvantages. Some preserve shape better, others preserve areas, and others preserve distances. The Mercator Projection is a type of map projection created by Gerardus Mercator in 1569 to represent the Earth's surface. It was widely used from the 17th century onward for nautical charts because it allowed constant compass routes to be drawn as straight lines. Unlike other more accurate map projections, it is a cylindrical projection tangent to the equator, and as such, it distorts the distances between meridians, making them appear farther apart as they approach the poles. This projection preserves the shapes of land masses between parallels, although it enlarges them more and more as they get closer to the poles, causing greater distortion of areas in high latitudes.
No entiendo.
Yo sí. Es que sí entendí la referencia.
¿Acaso no lo viste venir?
For example, places such as Canada, Greenland, Iceland, Russia, Europe, Alaska, and Antarctica appear much larger than they really are. However, places located on or near the equator such as India, Brazil, Africa, and Australia appear smaller than their actual size. For example, compare the size of Africa with Greenland. On a Mercator map, they appear to be the same size, but in reality Greenland is much smaller than Africa, by almost a factor of 14. The distortion of Greenland is so great that the size distortion in the Mercator projection is often referred to as the Greenland problem.
Esta historia continuará. De inmediato.
My name is Mónica Bella, and today I will explain two very important route concepts in marine navigation. First, the Great Circle, and second, the rhumb line. We will look at what each one is and how they different are, their advantages and limitations, and why the navigators use one or the other depending on the situations, because you can use both. These ideas are essential for planning safe and efficient voyage. Now I'm going to talk about what is the Great Circle. A great circle is the shortest part between 2 points on the Earth. It is called great because the plane that creates it passes through the center of the Earth. In navigation, it's very important and useful for long voyage because it reduces the distance, the time, and the fuel consumption. However, the course changes along the road, so it's not simple to follow manually. Now I'm going to talk about the advantage and limitations. The Great Circle route is the shortest part between 2 points on the Earth. Its biggest advantage is efficiency because it saves distance, time, and fuel. However, the navigator must keep changing the route during the trip which makes more difficult to follow manually. For that reason, it's especially useful on long ocean voyages where efficiency matters most. Okay, now I'm going to talk about the rhumb line. The rhumb line is a path that keeps the same angle with all the meridians so the navigator can follow one constantly heading. For example, on a Mercator chart, it looks like a straight line, which makes plotting easier. Even though if it is longer than a great circle, it is often preferred when simplicity and control are more important than saving distance.
1 hour later. A few moments later.
Now I'm going to talk about the advantage and limitations of the rhumb line. The rhumb line is easy to use because it keeps a constant bearing all the way. That is why it is very useful coastal or short distance navigation. The disadvantage is that it is not too short a route, so over long distance it takes more time and fuel. Near the poles it becomes less practical because the route tends to spiral. Why are both important for navigation? Great circles are ideal for long distance travel because they are most efficient route, and the rhumb lines are useful when simplicity matters more, such as in coastal navigation or short voyage. In practice, navigators may combine both in a composite route to balance the efficiency and safety. Finally, in this image, we can clearly see the great circle concept. The red line shows the shortest route between the 2 points, in this case, New York and Paris. Even though it looks curved on a flat map, it actually represents the most efficient part over the Earth's surface because the Earth is spherical. We can also notice that this route don't keep the constant heading. That means that as the ship moves forward, the navigator must constantly adjust the course to stay on a great circle arc. This is why the great circle has a major advantage in distance, but is more difficult to navigate manually. The image also shows us that the great circle effect becomes more dramatic near the poles. This is important because in those regions, the curve becomes more noticeable and the difference between the great circle route and rhumb line can be greater. For that reason, on long-distance voyage, especially between continents, the route helps save time, fuel, and even though it requires more course corrections along the way. The inset map at the bottom also helps to compare how the route appears on a flat chart, and it shows that although it looks like a curve, it is actually a short distance on the sphere. This makes it easier to understand and why a great circle navigation is so important in maritime and air route planning.
¿Vieron eso? Eso es ser bárbaro.
My name is Leslie Núñez. Today to talk about Gnomonic Projections. What is a Gnomonic Projection? A Gnomonic Projection is a flat map projection used primarily in maritime navigation. It is obtained by projecting the Earth's surface onto a tangent plane, using lines that originate from the center of the Earth. The most important is that great circle route. The shortest paths between 2 points on the planet appear as straight lines. Thanks to this, navigators can plan more efficient maritime routes, reducing travel time and fuel consumption. Characteristics: straight geodesy. The shortest maritime routes on Earth appear as straight lines, making it easier to plot trajectories. Central accuracy. Skill and accuracy are more precise near the points where the plane touches the Earth. Progressive distortions, limited converse, strategic use. Advantages: rapid route identification allows for the easy identification of the shortest maritime route between two ports. Your savings improves strategic planning, geometric simplification, nautical importance. Disadvantages: high distortion, area far from the center appear exaggerated and lack precisions. Inaccurate distances reduce convergence. It cannot correctly display entire hemispheres. Does not maintain constant headings, limited use. Example of Gnomonic Projection application in navigation: planning ocean routes, safety navigation waypoints, choosing efficient departure routes from ports, converting routes to Mercator cards, optimizing fuel and traversing in shipping routes. Conclusion: the Gnomonic Projection is a fundamental cartographic tool for maritime navigation because it simplifies the calculation of great circle routes. Although it presents significant distortion far from the center, it remains essential for the strategic planning of long and efficient oceanic journeys.